This recording is to help you with Lesson 1.01, Introduction to Functions. Alright, let's start with 29 here. It says, evaluate the function at the specified values of the independent variable and simplify. So we are given f of 4 to start with. So what we're going to do is we notice that the 4 is in the y spot. So we're going to plug in a 4 anytime we see a y. So looking down here, we'd have 3 minus the square root of 4. Well, we know that the square root of 4 is 2. So 3 minus 2 equals 1. Now we're going to do the same thing, now, except we're going to plug in 0.25 for y. So we have 3 minus the square root of 0.25, and then we get 2.5. Then we have to plug in 4x squared in for y. So we get 3 minus the square root of 4x squared. So we get 3 minus, so the square root of 4 is 2, and the square root of x squared is just x. But they're going to put the absolute value sign along there because we don't want x to be negative here, because it would change that minus to a plus sign, and that's not what our starting function was. So they just threw in that absolute value sign. The next thing we have is what we call a piecewise function. And it's a piecewise function because it depends upon what x is, and that will tell you which piece to use. So if f is -1, which piece am I going to use? X greater than or equal to 0 or less x less than 0. Sorry. Well, -1 is less than 0, so I am going to use the first function listed here of 2x plus 1. Okay, so I am going to plug in -1 anywhere I have an x. So that's how we get 2 times -1 plus 1. And when I simplify that, I get an answer of -1. Now, which piece am I going to use for 0? Well, since it's equal to 0, I use the second function of 2x plus 2. And I'm going to plug in 0 for x right here. So 2 times 0 is 0. 0 plus 2 is 2. And then last, I have f of 2. Well, 2 is greater than or equal to 0. So again, I'm using that second function. So 2 times 2 is 4. 4 plus 2 is 6. So that's how they get the answer of 6. For the next one here, it says find the values of x for which f of x equals g of x. So I need to set my two functions equal to each other and solve. So I have x squared equals x plus 2. Let's start by getting everything to one side. So I'm going to subtract the x and subtract the 2. So I get x squared minus x minus 2 equals 0. From here, you can use the quadratic formula to solve for x, or you can try to factor it. And this does factor to x plus 1 times x minus 2. And then we set each parentheses equal to 0 to solve. So you'd get x plus 1 equals 0, x minus 2 equals 0. That means x is -1 or 2. For the next one, it says find the domain of the function. All right, we have a fraction here. So if we have a fraction, we know that the denominator cannot be 0. But it can be any other number as long as the denominator is not 0. So here our domain is all real numbers except t equaling 0. Okay, then lastly, let's see here. Find the difference quotient and simplify your answer. All right, so here is our difference quotient, and we know that g of x is 3x minus 1. So that's what I'm going to start with, g of x. And all the work is there, but I'm going to do it by hand here, so hopefully you can try to follow along. So g of x is just 3x minus 1. Then I have minus g of 3. So anywhere I have an x, I'm going to plug in a 3. So here I have 3 times 3 minus 1, all over x minus 3. Notice that there's no g of x minus 3, so I don't need to do anything with the denominator. Okay, let's simplify the numerator. So it's just going to say 3x minus 1 minus 3 times 3 is 9. 9 minus 1 is 8. So I have a minus 8 there. Let's see. So 3x negative 1 minus 1 is a negative 9 all over x minus 3. I can factor out a 3 in the numerator, and I'm going to switch colors here so we can just see that. And I still have an x minus 3 in the denominator. I have an x minus 3 and an x minus 3 the same, so we just have 3. And we do have a restriction there, x cannot equal 3. And we know that x cannot equal 3 because that would give us 0 in the denominator. So 3 would be our answer for 75.